Okay, so we're going to be looking at the moment and gears calculation sheet from P8.4, specifically at question 3. Now, if you've made it up until this point, understanding that's really well done, because this question is very, very hard, and what we're going to do is A-level standard. So this is the hardest type of question you will ever get on GCSE. If you can understand these methods, then you will be able to do any moments question that they hit you with. This sort of question will only be on a higher paper, and it will be maximum marks because it's a very difficult question. So before we start though, let's just go back to basics. We know that moments are force times the perpendicular distance from the pivot. Now that's the key. We always say distance, but it is from the pivot. We're used to seeing our seesaw here like so, in the middle, and we've got person here who is A and person here who is B. Now, we always just say the moments on the left equal the moments on the right. But how do we actually know that, and what are we doing? Actually, to do that, we are taking our moments about the pivot. We have decided that that central point is where we are going to take our moment from. And what we've actually ignored is that that pivot, that support, actually has an upward acting force, like so. So by taking our moment in the middle, we're almost deleting it so we don't have to think about it. Because if we say we're going to take the moments about the middle, if I call this S for support, if you were to look at that S point and take the moments of it, well, S is your force. Let's say S equals 10 for the moment. If you were going to do force times distance of this central point, your force is 10. What's your distance from your pivot? Well, you're on your pivot, so your distance is 0. 10 times 0 equals 0. So that is how you delete that part of it, and you don't have to think about it. So every time you are saying the moments on the left equal the moments on the right, there is this secret support moment that you are actually deleting and not paying attention to. But if you wanted to, you could take moments about A or about B or about any point on that beam to get the same answers. So if we go back to our seesaw here, now let's draw our pivot in the middle. We've got a force here and we've got a force here. Now let's say that to A it is 2 meters and to B is also 2 meters. Let's say that A weighs 10 newtons. And B is what we don't know. So I'm just going to put F because we don't know what it is. And then in the middle, we do have a support. Now, if this is a balanced beam, we know that equal and opposite forces. So that support, that force pointing upwards, S, must equal the two forces pulling it down. That's the whole reason it's able to support. So we know that S must equal 10 newtons plus F. We know that, otherwise your beam would not work. So we're happy that S equals the combination of the weights on the beam. That is how a seesaw is built, otherwise they'd never ever work. But if we now take moments about it, and we say we need to know what F is, we can take moments about S, okay? So just like we always do, if we take moments about our central pivot here, if I put moments about S, you are going to end up with what we always end up with, because we know that S times distance, the distance from the pivot is 0, so it will just disappear. So you're going to end up with the moments of A, which is 10 times 2, equals the moments of B, which is F times 2. Nice and simple. Rearrange and you would hopefully end up with F equals 10 newtons. Now, we know if we pop that back in, that S should equal 20 newtons because S is supporting both of them. But let's try and prove it an alternative way. This time, let's take moments about B. So we're going to take moments about this point. And we're going to have to start considering which way things move, because you can see that S goes up and 10 goes down. And we're always talking about moments being the turning effect of a force. So if we draw our seesaw again, if I do A going down and B going down, and let's consider our central pivot. If I ask you which direction those are going, you wouldn't say down. But if I ask you which way are they turning, that's when they are opposite. Now consider B. If you were to put your finger on that pivot now and pull down on a piece of string at B, that seesaw is going to go down, 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 and eventually turn this way, like so. And that is clockwise. Now, if you put your finger back on the pivot and you pull on the string at A is going to go down, 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 but it's going to go the other direction, in anti-clockwise. And this is where you are really at A-level standard, because A-level is all about clockwise and anti-clockwise motion. But that is what's going to help you do this question. So if we go back to our seesaw with S up here, I'm going to take moments about B. So let's redraw that just to make it easier. So we've got our seesaw with our central pivot. We know that the pivot is supporting our beam. So you've got an S support. A is sat over here. We said A was 10 newtons. And they are a distance of 2 meters from the pivot. B is sat over here. I'm going to leave it as F because we're not going to need it. But you can put in the numbers if you want. And that is still 2 meters. So remember, this is A and this is B. Now, last time we took moments about S, and that was nice and easy. But this time we're going to take moments about B. So just over here. So when I say take moments, you need to imagine now that if this was a beam, you are going to put your finger on that point and you are going to make it move like a clock handle. So to show, I'm going to say moments about B, like so. And what I'm going to say is that anything moving in a clockwise direction is going to be a positive, and anything moving in an anti-clockwise direction is going to be negative. So I'm going to put that arrow, which is a clockwise, with a little plus, so you can remember that, okay? And that's how we notate moments. Now remember, guys, this is A-level standard, so don't worry if this is proving a little bit difficult. We're going to do a few. So moments about B, and that's in the clockwise direction. So I've put my thumb on B, and I'm going to move along my beam to the left, and the first force that I come into contact with is S. Right. S, if I now pull on that bit of string, that beam is going to go up, 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 and it's going to start to go round in this way. That is a clockwise direction. Right, so I know S is positive. So S, don't need any negatives in front, and it is 2 meters from point B. Times by distance, so force times distance. Right, that's my moment for the first one. But I've got a second force over here. I can't ignore, I have to include that. So I'm going to keep working along my beam. Remember, my thumb is on B, and I'm going to get to A. I've moved a whole 4 meters now from B, so it's 2 plus 2 equals 4. Now, my force is 10 newtons, so I know there's going to be a 10 in there. But if I put my thumb on B and I pull down on my string of A, it's going to go down, 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 and it starts to turn like so. That is anti-clockwise. So you can see that S is turning clockwise, 10 at A is turning anti-clockwise. So that's going to mean that this is a negative. Negative like so. Now, so I've got my minus 10 force times my perpendicular distance from my pivot. So from A to B is 4 meters. Now, our beam is not moving. It's balanced. So we know that balanced forces must equal 0, like so. So I'm now going to rearrange just to check my answer. So we've got 2s minus 40 equals 0. So 2s equals 40. Divide both sides by 2, s equals 20 newtons. Now if we go back and check our previous calculations where we proved that the support force must equal the two weights it's supporting, and we said it must equal 20 newtons, if I can find it. Did we write it down? No. There we go. But we have now proved that we can take moments from any point. So we can do it again. We can take our moments from A if we want. So let's give that a go and prove that B is the same answer as we found before. So I've got my pivot. I've got my person sitting at A, which is 10 newtons. And I've got my person sitting at B, which we said was F. They're both 2 meters from the middle, like so. And I've got my S support. And we've now calculated that S is 20 newtons. So I'm going to put that in because we now know it's there. Okay, so we're going to take moments about A. This is A and this is B. So moments about A. And again, I like clockwise being a positive and anti-clockwise being a negative. So I'm going to do my arrow in a clockwise direction and I'm going to put a positive notation. Right, so put your thumb on A over here and now imagine you're pulling that invisible string to turn your rod. So if I'm going to take moments about A is 10 newtons here, but the distance from A is 0, so it immediately disappears. I can even write that, 10 times 0, well, you know it's going to cancel out because anything multiplied by 0 is 0. Right, let's move along the plank to the right. The next thing I hit is the main central pivot at S, and that's 20 newtons. Right, so I know there's going to be a 20 newtons here. But is it positive or negative? Well, put your thumb on A and pull that invisible string upward. It's going to go up, and it's going to start to curl round in this direction. That is anti-clockwise, just like a clock hand. So we know that anti is negative. Right, how far is that 20 newtons from your pivot? Well, we can see it's 2 meters, so it's 20 times 2. Right, keep moving along your beam. We're on to the next one. We've got to B. We know that there is a force F. We're assuming we don't know the value of F at the moment. Now, if you pull down on that string, so your thumb is on A, and you're pulling down on that invisible string, pull down. If it will let me draw it. As it goes down, it's going to start to turn in this direction. And that is the clockwise direction, which you've decided is positive. So you're going to put a plus there. Right. Now, how far is F, or point B, from your pivot? Well, you're starting at A. So you've got 2 meters plus another 2 meters is 4. So it is a distance of 4 meters. And that is all your forces on your beam. It's a balanced beam, so it must equal 0. Put it up here, because it won't let me write. There we go, equals 0. And all we need to do now is rearrange. Right, well, 10 times 0 is 0, so we'll get rid of that. Minus 20 times 2, so minus 40. Plus F times 4, so plus 4F, equals 0. Rearrange, so you've got 4F equals 40. Divide, F equals 10 newtons. Exactly the same answers when we took moments from the middle. So you can see that we can take moments from any point, as long as you take into account your anti-clockwise and your clockwise motion. So let's tackle this question on 8.4. Now guys, remember this is a high standard, so do not worry if you're finding this difficult, it is tricky. So I'm going to draw again the diagram that they've shown us. So they've got the pole, they've got a force here which was FR, they've got a force upward which was FL, they've got a force downward here that was FG. They've told you the distance between these two are 2.7 meters. They told you the distance between these two is 0.7. And they have also told you that FG is 98 kilos. So 98 newtons. Right, so that's the information they've given us. I'm immediately going to fill in the blanks. I can now figure out that this is 2 meters by subtraction. And your FL and your FRs are unknowns. And those are what we're looking for. So for part A, they want you to calculate the force of FL. So for part A, we're looking for FL. That's what we want. Now, we know that if you've got 2 unknowns in an equation, you cannot do it, okay? So we really want to get rid of one of these unknowns. We're looking for FL, so we need to find a way of getting rid of FR. We know that anything you multiply by 0 will disappear. So let's, to start off with, take our moments about the point at FR, about point R. So I'm going to write here moments about R, okay, because that's point R. So this is R, this is L, and this is G. So I'm going to take moments about R. Let's keep it the same. Let's keep our clockwise motion being positive. Right, start off, put your thumb at R and move along the pole. The first thing you come into contact is point L. Right, so that is an unknown force. So we know we're going to have FL. That's going to be our unknown. And is it going to be a positive or a negative? Well, we know that clockwise is positive, so put your thumb on R and start to pull up on that invisible string. It's going to go up, 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 and it's going to start to turn this way, like a clock handle. That is anti-clockwise, so it's going to be a negative FL because it's anti. What is the perpendicular distance from your pivot? Well, it's 0.7 meters from R to L, so we're going to times that by 0.7. Okay, first point done. Right, let's move along now, along the pole, and you get to point G, because we've just done L. So G, they've given you the value. They told you it's 98 newtons, so we're going to put a 98 here. 98, there we go. Now, is it positive or negative? Put your thumb on R and pull down on that invisible string. So as you start pulling down, it's going to start to turn like a clock handle, and it's going to turn this direction. That is a clockwise direction. We have decided here that clockwise is positive, so you're going to put a plus. And what is your distance now from R to G? It's the perpendicular distance from your pivot. Well, they've given you here 2.7 meters. So you're going to times it by 2.7. And then he's not moving, he stood still. That's all our forces, so we know the resultant force must be 0. Right, all you need to do now is rearrange and pop into a calculator. So you've got minus 0.7 FL. Add 98 times 2.7, let's pop that into a calculator, is 264.6 equals 0. I like to put things on both sides to make it look nice for myself, so I'm going to say 264.6 equals 0.7 FL. I've just added it to both sides to get rid of that negative. And then I'm going to divide both sides by 0.7. So FL equals 378 newtons. And if you check the answers, that is correct. So we've done that first bit. Good job. Okay, next one, part B. They are looking for FR. So part B is now looking for FR. Now, we've now got rid of one of our unknowns. So we could do it by simple understanding that all of the upwards forces equal all of the down forces. So we could just say that the upward force of FL must equal the downward forces of FR plus FG. So we could do that and then rearrange. So if we were to do that, we'd say 378 equals FR plus FG, which was 98. So FR equals, which way am I going? 378 minus 98. Pop that into a calculator, which should give you 280 newtons. And there is nothing wrong with doing it that way. That is absolutely fine, and that is the correct answer. But let's prove we could do it by taking moments again. So you can take moments about point L or about point G. It's completely your choice, but I'm going to now take it about point G. So I'm going to take my moments over here. Just because I like being at either end of the pole. It's easier than being in the middle for me. But there's absolutely no difference. Right, so let's start off at G. We know that even though G is 98 newtons, the distance from the pivot is 0, so that's going to disappear. So we're going to move along from G to the left. Actually, I will redraw this just to make this a little bit easier so we can work down here. So we've got our pole, this is G, this is R, and let's put in actually the values that we now know. We're looking for FR. We know that FL is 378. And we know that G is 98 newtons. We know that this is 0.7, this is 2, and this is 2.7. Okay, this is our diagram. We're happy where we are. So we're taking moments about point G over here. Right, so put your thumb on G and start to move along the pole to the left and see where you get up to. The first point you should come into contact with should be L, just about here. So we're going to take moments about G and we're sticking with our clockwise direction. Moving along, we've come to L, which is 378 newtons. Now pull up on that string and decide which direction are you going to turn. Your thumb is on G. You're going to go up, 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 and you're going to start to go round this way. And that is a clockwise direction, which is good. This stays positive. We like positives, nice and easy. How far is that 378 newtons from the pivot of G? Well, here we worked out it was 2 meters. So we're going to times that by 2. Now, move on to the next one. Keep going left, you get to point R. Right, that's our FR. That's what we're looking for. So I'll put it here. Now, is it positive or negative? Put your thumb on G and pull down on that string of FR and see which way you turn. So you'll start to go down, and as it starts to turn, you're going to start to go this way, which is anti-clockwise. That's going to be a negative there. And now, how far is FR from the pivot? Remember, it's always the perpendicular distance from the pivot. It doesn't matter that you've got 2 forces next to each other. You have to take the distance from the pivot to the force you're looking at, which is the 2.7 meters here. So 2.7, and there's no other forces. The beam isn't moving, so we're going to say it equals 0. Right, now let's prove and see if we get the same answer as our other method. So 378 times by 2 is 756, and it's still positive, minus 2.7 times FR. You didn't need the brackets there, but I just did it, equals 0. Let's rearrange. So 756 equals 2.7 FR. Divide both sides by 2.7. And hey ho, you get 280 newtons. So hopefully now you have an idea about how to take moments from a point, but you can do the method we did at the beginning of B here, as long as you've done the methods for 1 point. You can do that, but you can't do it if you've got 2 unknowns. It's all about that invisible string. Which direction is it going to turn? And as long as you have decided which direction is positive, then you should be fine. All of these questions, the beams or the poles will be balanced. They will not be moving, so your resultant forces will be 0. And you just make them equal to each other like so. Now, if you're confused about where we normally go with this, because we normally say one side equals the other side, if I just pop this here, go back to our seesaw. This is A, this is B, let's say this is 2, say this is 3, even though it's not drawn to scale. This is 10, let's do S here, and let's do, let's say this is X. That's what we don't know. Right, let's just prove that whereas we could just say one side equals the other side, we can do our normal method one more time just to show that we understand. We're going to take moments about S. In the clockwise direction is positive. So I've got my thumb on S. I'm sticking to the middle. First, I'm going to go to the left. Right, at point A, I've got a weight of 10 newtons. These are newtons. Now, if you put your thumb on S and you pull down on that string at A, down, 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 it's going to turn this direction, which is anti-clockwise. So I can put a negative here. Now, what is the distance from A to S? Well, it's 2 meters, so I'm going to put a 2. Right, let's go back to our central point, to our pivot. Our force is now on the other side. So go all the way across to B, and you've got a force of X. What is the distance? It's 3 meters. But what is the direction? That's what we need to do. Well, put your thumb on S and pull down on that string. So both A and B are downwards, but you're now going to notice that if you pull down, this one goes clockwise. That's going to be a positive. Right, the beam's not moving, so it equals 0. If you now rearrange this, if I say, so I've got 20 here, plus 3x, minus 20, plus 3x equals 0. Move it onto the other side, 3x equals 20. So it's exactly the same as when we say one side equals the other side. We've just done it all on one side of the equals instead this time. So it's the same method, just makes it a little bit easier for when you've got more than 2 forces or you don't have a clear pivot. And I hope that makes that question a little bit easier.